Imagine flying over Europe in 1944. Below you, the continent is burning. American B-17s and B-24s are crossing the sky in enormous formations. British Lancasters are attacking German cities at night. Fighters are waiting above the clouds, searching for bombers. Then, suddenly, something appears. It doesn't sound like the piston-engine fighters everyone knows. It doesn't move like them either. It accelerates with terrifying speed. For a few seconds, the pilots watching it have no idea what they are seeing. This isn't a normal fighter. It's a glimpse of the future. During World War II, Nazi Germany developed some of the most radical aircraft ever designed. Some were revolutionary. Some were desperate. Some were technically brilliant but impossible to manufacture in meaningful numbers. And some never made it beyond a prototype. These experimental aircraft represented a strange contradiction at the heart of Germany's wartime aviation program. German engineers were often thinking years ahead of their time. But the German war machine increasingly lacked the fuel, factories, raw materials, trained pilots, and time required to turn those ideas into effective weapons. The result was an extraordinary collection of aircraft that looked as if they belonged to another era. Rocket fighters, early operational jet fighters, flying wing bombers, high-speed interceptors, aircraft with unusual engine configurations, and designs that existed mostly on drawing boards. Today we're going inside that forgotten world. Not the famous fighters that dominated early war propaganda. Not simply the aircraft that entered mass production, but the prototypes, experimental machines, and advanced concepts that reveal where German aviation was trying to go, and why most of those dreams never became reality. This is the story of Germany's secret skies. The race to build the future. Before World War II, aviation was changing faster than almost anyone could imagine. The aircraft of the First World War had been fragile machines built from wood, fabric, and metal. By the late 1930s, aircraft were becoming faster, stronger, and more sophisticated. Propellers still dominated the skies. But engineers were already asking a dangerous question. What if an aircraft could fly without a propeller? The answer was the jet engine. In Britain, Frank Whittle was developing his ideas about jet propulsion. In Germany, Hans von Ohain and Ernst Haeckel were working on a similar revolution. Their work would eventually produce one of the world's first true jet aircraft, the Heinkel He-178. The He-178 was tiny by later standards. It first flew in 1939, just days before Germany invaded Poland. Its significance, however, was enormous. Instead of a piston engine turning a propeller, the aircraft used a turbojet. Air entered the front. The engine compressed it. Fuel was burned. And hot gases were blasted out of the rear. The result was thrust without a propeller. The technology was still immature. But the basic principle worked. Germany had entered the jet age. And that would eventually lead to aircraft that seemed almost unbelievable compared with the fighters of the early war. But technological breakthroughs don't automatically win wars. A revolutionary engine still needs factories. A revolutionary aircraft still needs fuel. And revolutionary pilots still need training. Those problems would become increasingly important as the war continued. The Me-262, the future arrives too early. If one aircraft represents the transformation of German aviation during World War II, it is the Messerschmitt Me-262. It wasn't merely a faster version of an existing fighter. It represented an entirely different generation of combat aircraft. The Me-262 began as an experimental project in the late 1930s. The first prototype flew in 1941, initially using piston engine propulsion during early testing because the jet engines were not ready. Eventually the aircraft was fitted with turbojets. And once the jet-powered version took to the sky, the difference became obvious. The aircraft was fast. Very fast. Its maximum speed was roughly 540 miles per hour, depending on configuration and conditions. For comparison, many of the best American and British piston engine fighters were significantly slower. The Me-262 could climb rapidly. It could accelerate away from conventional fighters. And its 430mm 108 Malawian Quachas cannons gave it tremendous firepower against bombers. To a bomber crew accustomed to seeing propeller-driven fighters, the Me-262 could appear almost supernatural. But the aircraft had a major weakness. Its engines. The Junkers Jumo 004 turbojet was revolutionary, but its early design had a short service life. The engines used materials that were difficult to obtain under wartime conditions. Germany simply did not have enough high-temperature resistant alloys to build extremely durable turbine components. As a result, the engines required frequent replacement. Fuel was another problem. Jet engines consumed valuable aviation fuel at a time when Germany was suffering from severe fuel shortages. And there was another problem that had nothing to do with engineering. Politics. The Me-262 was originally intended as a fighter, but Adolf Hitler became fascinated with the idea of using the aircraft as a fast bomber. That decision contributed to delays and confusion surrounding the program. By the time large numbers of Me-262s were finally becoming available, Germany's strategic situation had deteriorated dramatically. Allied aircraft were attacking German airfields. Factories were being bombed. Fuel supplies were collapsing. Pilot training was being reduced. The Me-262 was extraordinary. But extraordinary technology could not reverse a collapsing industrial system. Still, the aircraft proved something important. The future of aerial combat had arrived. And Germany wasn't finished experimenting. The Me-163 Komet, the rocket fighter of the Me-262, looked futuristic. The Messerschmitt Me-163 Komet looked almost impossible. It wasn't powered by a conventional piston engine. It wasn't even powered by a turbojet. It was a rocket-powered interceptor. The concept was simple in theory. A bomber formation is approaching. A conventional fighter needs time to climb. But what if an interceptor could launch from the ground and accelerate upward almost vertically? That was the basic idea behind the Komet. The aircraft had a tiny, streamlined fuselage and swept wings. Instead of a normal engine, it used a liquid-fuel rocket motor. The result was spectacular acceleration. The Komet could reach speeds far beyond most piston-engine aircraft. It could climb rapidly toward Allied bomber formations. And it could attack at altitudes where conventional fighters struggled. But there was a price. The rocket fuel was extremely dangerous. The propellants used by the Walter rocket engine were highly reactive and toxic. Ground crews had to handle them with extreme care. Even worse, the rocket engine consumed its propellants incredibly quickly. The Komet's powered flight time was therefore very short. The pilot would launch, accelerate upward, attack the bomber formation, then glide back toward the airfield. This created a bizarre combat experience. The aircraft was less like a conventional fighter and more like a manned missile. Its speed was impressive, but its operational limitations were severe. The Komet was difficult to land. The landing gear arrangement was unusual. The aircraft landed on a skid rather than a conventional retractable landing gear system. During landing, the aircraft was vulnerable. And because the rocket engine was no longer providing power, the pilot had only one chance to get the approach right. The Komet's greatest advantage, its extreme performance, was also its greatest danger. It was a weapon designed for a very specific problem. And that problem was becoming increasingly difficult to solve. Allied bomber formations were protected by large numbers of escort fighters. Even if a Komet could reach a bomber formation, it still had to survive long enough to make an attack. Its ammunition supply was limited. Its flight endurance was tiny. And its pilots faced one of the most unforgiving aircraft of the war. The Komet was a remarkable technological achievement, but it was not a miracle weapon. The Do-335, the strange fighter with two engines. Not every German prototype relied on jets or rockets. One of the most fascinating designs was the Dornier Do-335 file. Its appearance immediately separated it from conventional fighters. It had two piston engines, but they weren't arranged side by side. One engine was located in the nose. The second engine was mounted behind the cockpit. The rear engine drove a propeller at the back of the fuselage. This unusual arrangement was called a push-pull configuration. Why build an aircraft like this? Because conventional twin-engine aircraft created a major aerodynamic problem. Two engines mounted on the wings created drag. The Do-335's designers wanted twin-engine power without putting both engines in the wings. The result was an aircraft that looked strange but was remarkably fast. The Do-335 was also heavily armed and could carry weapons internally. It was designed to serve multiple roles: interceptor, fighter bomber, reconnaissance aircraft, heavy fighter, and potentially a high-speed attack aircraft. But the Do-335 arrived at the worst possible moment. Germany's aviation industry was under enormous pressure. Factories were being attacked. Components were scarce. Fuel was limited. And Allied air superiority made testing and deployment increasingly dangerous. Only a small number were completed. The aircraft never had the opportunity to demonstrate its full potential in combat. Yet its design remains fascinating. It showed that even near the end of the piston engine era, engineers were still exploring unconventional ways to extract speed from traditional technology. And then came an aircraft that took unconventional design even further. The HO-229, the flying wing. Perhaps no German aircraft prototype has captured the imagination of aviation enthusiasts more than the Horten Ho-229. At first glance, it doesn't look like a normal aircraft. There is no obvious fuselage, no conventional tail. Instead, the aircraft resembles a giant swept-wing shape, a flying wing. The concept was developed by brothers Raymar and Walter Horton. They were fascinated by the idea of eliminating unnecessary structures. A conventional aircraft has a fuselage, a tail, a cockpit, engine nacelles, and control surfaces. But all of those components create drag. What if the entire aircraft could become one aerodynamic surface? The flying wing concept offered the possibility of very low drag and high efficiency. The Hortons believed such an aircraft could achieve extraordinary performance. The eventual Ho-229 design was powered by two jet engines. That combination, a flying wing with jet propulsion, was revolutionary. The aircraft looked like something from decades later. But there is a crucial distinction between a prototype and a successful operational aircraft. The Ho-229 never became a mature wartime weapon. Development was incomplete. Testing was limited. Production never reached meaningful scale. Germany surrendered before the aircraft could become an operational system. The Ho-229 is often surrounded by dramatic claims about its supposed stealth capabilities. Modern discussions sometimes describe it as the world's first stealth bomber. The reality is more complicated. The aircraft's shape could potentially have reduced radar reflection from certain angles, and some design choices were interesting from a radar perspective. But the Ho-229 was never subjected to the kind of comprehensive stealth development, testing, and operational validation associated with modern stealth aircraft. It was an experimental machine, a glimpse of an idea. And that idea would later become extremely important in aviation. The Me-309, the fighter that was supposed to replace the Messerschmitt. Sometimes the most interesting prototypes are not the strangest. Sometimes they are the aircraft designed to replace something already successful. The Messerschmitt Me-309 was one such aircraft. Germany already had the famous Bf-109. But by the early 1940s, the Bf-109 was reaching the limits of what could reasonably be extracted from its basic design. Engineers wanted a more advanced fighter. The Me-309 incorporated several features that were intended to improve performance and pilot visibility. Its landing gear arrangement was unusual. Its cockpit offered a different approach to visibility. Its aerodynamics were more modern than the aging Bf-109. But development problems appeared. The aircraft was difficult to handle. Performance improvements were not sufficient to justify replacing the established Bf-109 immediately. And by the time the program matured, Germany's priorities were shifting. Instead of creating an entirely new piston engine fighter, the future increasingly belonged to jets. The Me-309 therefore became another dead end. But it demonstrates an important reality about technological development. Not every prototype fails because it is badly designed. Sometimes it fails because history changes faster than the engineers can finish their work. The Tu-183, the jet that arrived after the war. Near the end of the war, German aircraft designers were working on increasingly advanced jet fighters. One of the most famous was the Focke-Wulf Tu-183. Unlike many earlier aircraft, the Tu-183 was designed from the beginning around a jet engine. Its shape was extremely modern. It had a swept wing, a high-mounted tail, a streamlined fuselage, and a cockpit positioned toward the front. The aircraft was intended to become a next-generation interceptor. The design came from the Focke-Wulf team led by Hans Multhaup. The Tu-183 never reached operational service. In fact, it never completed a full flight test program during World War II. The war ended before the prototype could become reality. But the story didn't end there. After the war, German engineering knowledge was examined by the victorious powers. Aircraft designs, technical documents, engines, weapons, and production methods were studied. The Tu-183's general configuration also became part of the post-war conversation about swept-wing jet fighters. This doesn't mean that later aircraft were simply copies of German designs. Jet aviation was evolving rapidly in several countries at the same time. But the German experiments demonstrated that engineers were converging on similar solutions. As aircraft approached the speed of sound, straight wings became increasingly problematic. Swept wings offered a way to delay the effects of compressibility. And the Tu-183 embodied that new aerodynamic thinking. It was a prototype that never flew. Yet its shape seemed to point toward the future. The He-162, the people's jet that came too late. By 1944 and 1945, Germany faced an aviation crisis. Its experienced fighter pilots were disappearing. Fuel was running out. Factories were being destroyed. The Luftwaffe needed fighters. Thousands of them. And it needed them immediately. The answer was the Heinkel He-162. The concept was radical. Build a simple jet fighter quickly. use fewer scarce materials, simplify manufacturing, and train pilots to fly it with minimal preparation. The aircraft had a distinctive appearance. Its turbojet engine was mounted above the fuselage. The wings were relatively compact. The aircraft was lightweight, and it was designed for rapid production. But speed of development came with enormous risks. The He-162 program moved incredibly quickly. There was little time for extensive testing. The aircraft had structural and mechanical problems. The pilots expected to fly it were often inexperienced, and the operational situation was collapsing. The He-162 was not a magic solution. It was an emergency response to an impossible situation. A jet fighter is already difficult to operate. Now imagine giving that aircraft to pilots who have barely completed their training. Imagine doing it while enemy aircraft dominate the skies. Imagine having factories under attack. And imagine having almost no fuel available for training. That was the environment in which the He-162 appeared. It was technically impressive that the aircraft existed at all, but it arrived far too late. Germany surrendered in May 1945. The He-162 had almost no opportunity to change the course of the war. The Arado Ar-234, the jet bomber that actually flew. While the Me-262 is remembered as Germany's famous jet fighter, another aircraft deserves attention. The Arado Ar-234. It was designed primarily as a high-speed reconnaissance aircraft and later adapted for bombing missions. The Ar-234 was powered by turbojet engines. Its sleek shape allowed it to reach speeds that made interception difficult. For reconnaissance missions, this was a major advantage. The aircraft could fly over enemy territory at high speed, gather information, and attempt to escape before fighters could catch it. Later versions carried bombs. The Ar-234 therefore became one of the world's earliest operational jet bombers. But once again the numbers were tiny. Germany simply could not produce enough advanced aircraft to make a decisive strategic difference. And that leads to one of the most important lessons of the entire story. A prototype is not an army. A prototype is a possibility. To transform that possibility into military power, a country needs an enormous industrial ecosystem. It needs engines, factories, spare parts, fuel, airfields, maintenance crews, weapons, pilots, training aircraft, and time. Germany increasingly lacked all of them. The American bomber problem. To understand why these prototypes mattered, we have to look at the enemy they were designed to fight. By 1943 and 1944, the United States was sending massive bomber formations over Europe. The B-17 Flying Fortress had become a symbol of American air power. Its defensive guns made attacking from predictable angles dangerous. Later, long-range escort fighters such as the P-51 Mustang changed the equation dramatically. American fighters could accompany bombers deep into German territory. This meant German interceptors could no longer assume that bombers would be isolated. The Luftwaffe faced a brutal mathematical problem. It needed to destroy bombers quickly, and it needed to survive the escort fighters. Traditional fighters could attack, but the bomber formations were becoming too heavily defended. This created demand for heavier weapons, higher speed, higher altitude, and faster climb rates. That environment encouraged experimental designs. Rocket fighters, jet interceptors, heavy cannons, high-speed aircraft, unusual aerodynamic configurations. The German aircraft industry was trying to solve an increasingly impossible tactical problem. The rise of the Wunderwaffe idea. By the final years of the war, German propaganda increasingly promoted the concept of revolutionary weapons. The term Wunderwaffe, meaning wonder weapon, became associated with advanced technologies that were supposedly capable of changing the war. Some technologies really were revolutionary, but the propaganda surrounding them created unrealistic expectations. A new aircraft could be astonishing, but one aircraft could not replace thousands of conventional fighters. A rocket fighter could climb faster, but it could not solve the fuel crisis. A jet could outrun enemy fighters, but it could not create trained pilots overnight. A flying wing could be decades ahead aerodynamically, but it could not survive a collapsing industrial system. This distinction is critical. Germany was not losing because its engineers suddenly became incapable. In many areas, German engineers remained extremely creative. Germany was losing because engineering existed inside a larger war. And wars are not won by technology alone. The aircraft that never escaped the drawing board. For every experimental aircraft that reached a prototype stage, many more existed only on paper. Design offices across Germany produced concepts for high-speed fighters, bombers, interceptors, reconnaissance aircraft, and advanced engines. Some were practical. Some were wildly ambitious. Some were technically impossible with the materials available. Others might have worked if the war had lasted longer. But drawings are not aircraft. A design on paper must survive the transition to reality. Engineers have to discover unexpected problems. Pilots have to test handling characteristics. Structures must withstand vibration. Engines must survive heat. Weapons must work. And every component has to be manufactured repeatedly. That last part is often overlooked. A prototype can be hand-built by highly skilled workers. Mass production is completely different. Thousands of identical components must be manufactured to consistent standards. The aircraft has to be easy enough to assemble. Workers need instructions. Factories need machines. Materials need transportation. And damaged aircraft need replacement parts. The German prototype programs frequently encountered these problems. Why Germany could build amazing prototypes but not enough aircraft. This is perhaps the greatest mystery surrounding Germany's late-war aircraft. How could a country struggling to produce basic military supplies continue creating such advanced machines? The answer lies in the difference between innovation and industrial capacity. A small engineering team can design something extraordinary. A factory network must then reproduce it thousands of times. By 1944, Allied bombing had severely damaged German industrial infrastructure. German production was increasingly dispersed. Factories moved underground or into forests. Production lines were disrupted. Transportation networks were attacked. Oil production was targeted. Fuel became scarce. The aircraft themselves became less important if they couldn't fly. A perfect fighter sitting on an airfield without fuel was useless. A factory capable of producing engines was useless if electricity, raw materials, or transportation were unavailable. This is why the prototype story is ultimately a story about systems. The pilots who had to fly the future technology also changes the human experience of war. German pilots who flew early piston engine fighters had trained for years. They understood engine management, energy fighting, dogfighting, formation tactics, navigation, gunnery. But jets behaved differently. Acceleration was different. Engine response was different. Landing speeds were higher. Fuel consumption was different. And the aircraft could punish mistakes much more quickly. The Me-262, for example, could be extremely vulnerable during takeoff and landing because its jet engines responded differently from piston engines. Enemy pilots learned to attack jets when they were most vulnerable. A technically superior aircraft still required skilled pilots. And Germany increasingly lacked those pilots. The experienced men were gone. New recruits were being trained under compressed schedules. Fuel shortages limited flight hours. The result was tragic. Some of the world's most advanced aircraft were being handed to pilots who simply didn't have enough time to master them. The Me-262 against the Mustang. Imagine the tactical situation. A German Me-262 enters the sky. It is faster than the American fighters pursuing it. That sounds like an easy victory. But speed alone doesn't guarantee survival. The Me-262 needs to land. It needs fuel. Its engines need maintenance. Its pilot needs experience. And its airfield can be attacked. The P-51 Mustang, meanwhile, has a major advantage. It can remain in the air for long periods. It can escort bombers. It can patrol German airfields. And it can attack aircraft during takeoff and landing. This created a paradox. The Me-262 could be the better aircraft in a direct high-speed encounter. But war isn't a laboratory test. The aircraft that wins a specification comparison doesn't necessarily win the campaign. Logistics decide campaigns. Numbers matter. Training matters. Availability matters. And Germany was losing on all of those fronts. The fight for raw materials. One of the least glamorous parts of aviation history is also one of the most important. Materials. Jet engines operate at extremely high temperatures. The turbine blades must survive enormous thermal and mechanical stress. Modern engines use advanced alloys and manufacturing processes to withstand these conditions. In wartime Germany, those materials were limited. Engineers therefore had to compromise. Some German jet engines were built with relatively low durability compared with later designs. That doesn't mean the engineers were incompetent. They were working under constraints. The aircraft industry needed materials. The Navy needed materials. The Army needed materials. Tank production needed materials. Artillery needed materials. Factories needed electricity. And fuel had to be distributed across the entire military. A technically brilliant design could be defeated by a shortage of a single material. The strange beauty of experimental aircraft. There is something fascinating about prototypes. They are unfinished ideas. They exist between imagination and reality. A production aircraft has to obey practical rules. A prototype can explore possibilities. That is why experimental aircraft often look strange. Designers can try a new wing, move an engine, remove the tail, add a rocket, change the landing gear, experiment with materials, or create an entirely new configuration. The German aircraft industry during World War II became a laboratory for these experiments. Some ideas failed immediately. Others worked surprisingly well. And several concepts would become important after the war. The post-war shock. When Germany surrendered in 1945, the prototype story entered a new phase. The war was over. But the technology was not forgotten. American, British, Soviet, and French technical teams examined German aircraft. Captured aircraft were transported for testing. Documents were collected. Engineers were questioned. Factories were inspected. The victorious powers wanted to understand what Germany had developed. And they discovered an aviation industry that had explored a remarkable range of concepts. Swept-wing jets, turbojets, rocket propulsion, flying wings, high-speed reconnaissance aircraft, advanced aerodynamic research. These technologies did not suddenly appear in the post-war world because Germany had invented everything. Engineers in Britain, America, and the Soviet Union were independently working on many of the same problems. But the German experience provided valuable technical information. The jet age was accelerating. And now the war was no longer limiting its development. The Ta-183 and the new jet age. After the war, swept-wing fighters quickly became a dominant feature of military aviation. Aircraft such as the American F-86 Sabre and Soviet MiG-15 demonstrated how rapidly jet technology had evolved. These aircraft were not simply World War II prototypes brought to life. They represented a new generation. But the German wartime designs had already demonstrated many of the fundamental ideas. The future was no longer theoretical. It was arriving. And it was arriving faster than anyone expected. What if Germany had built thousands of jets? This is where history becomes tempting. What if Germany had produced the Me-262 in 1943? What if thousands of jet fighters had entered service earlier? What if the He-162 had been developed under normal conditions? What if the Ho-229 had become operational? What if the Ta-183 had flown before the war ended? Would the outcome of World War II have changed? The answer is probably more complicated than popular stories suggest. Earlier jets could have inflicted heavier losses on Allied bomber formations. They could have made air operations more dangerous. They might have prolonged Germany's ability to defend parts of its airspace. But Germany still faced enormous disadvantages. The United States had immense industrial capacity. Britain retained major aviation capabilities. The Soviet Union was producing huge numbers of combat aircraft. The Allies controlled enormous resources. And by 1944, the strategic balance was overwhelmingly against Germany. Technology could have changed the cost of victory. But changing the outcome would have required much more than one revolutionary aircraft. The myth of the secret superweapon. Modern audiences are naturally attracted to secret weapons. The idea is irresistible. A hidden aircraft. A forgotten machine. A secret design that could have changed everything. But history is rarely that simple. The German prototype aircraft were not magic. They were engineering experiments created by brilliant people working under extraordinary pressure. Some succeeded. Some failed. Some were too expensive. Some were too complicated. Some arrived too late. And some were overtaken by the rapid development of competing technologies. Their real significance is more interesting than the myth. They show how quickly aviation was changing. The human cost behind the machines. There is another side to these aircraft that should never be forgotten. The German wartime aviation industry operated within the Nazi dictatorship and the brutal system of forced labor. Many factories relied on prisoners and forced laborers who worked under terrible conditions. Underground production facilities were often associated with extreme suffering. The technological achievements of these aircraft cannot be separated completely from the human cost of the system that produced them. This matters because technological history can easily become romanticized. A beautiful aircraft can distract from the people who built it. A revolutionary engine can distract from the conditions inside the factory. A futuristic prototype can distract from the war itself. The machines were impressive. The circumstances surrounding them were often horrific. The aircraft that became symbols. Today, surviving German aircraft from the World War II era are displayed in museums around the world. Visitors can stand beside a Me-262 and see how compact it actually was. They can look at the Ho-229 and understand just how unusual its shape was. They can examine the Me-163 and realize how small the rocket fighter really was. But seeing these aircraft today creates a strange feeling. They look clean, silent, frozen. The engines aren't screaming. The guns aren't firing. The airfields aren't under attack. The aircraft appear almost peaceful. Yet every one of them was designed for a war that killed millions. That contrast is one reason aviation museums matter. They preserve the technology while giving us an opportunity to remember the history around it. Why the Me-262 matters today. The Me-262 is often described as the world's first operational jet fighter. That achievement alone makes it historically significant. But its deeper importance is that it marked a transition. For decades, the propeller had been the defining feature of powered flight. Now the turbine engine was taking over. The sound of aviation was changing. The shape of aircraft was changing. The speed of aircraft was changing. And the battlefield was about to change with it. Within a few years, jet fighters would become normal. Within a few decades, supersonic flight would become routine for military aircraft. The Me-262 belonged to the beginning of that transformation. Why the Ho-229 still captures imaginations. The Ho-229 has become famous far beyond its actual wartime impact. Part of the fascination comes from its appearance. It looks like a modern stealth aircraft. That visual similarity encourages people to imagine a direct connection between the aircraft of 1945 and stealth bombers developed decades later. The reality is more nuanced. Aerodynamics, radar science, materials, electronics, flight controls, and manufacturing technology all evolved enormously after World War II. The Ho-229 did not possess the sophisticated stealth systems associated with modern aircraft, but its basic aerodynamic philosophy was undeniably unusual. Reduce drag. Integrate the aircraft. Use a flying wing configuration. Think differently. Those ideas remain relevant today. Why the Me-163 was both brilliant and terrifying. The Komet represents another lesson. Extreme performance always comes with trade-offs. The aircraft could climb incredibly quickly, but its endurance was tiny. Its propulsion system was powerful, but its fuel was dangerous. Its speed was extraordinary, but landing was hazardous. Its mission was specialized, and specialized weapons often struggle when the battlefield changes. Modern military aircraft still face the same principle. More speed means more fuel consumption. More weapons mean more weight. More range means larger fuel requirements. More stealth can mean higher cost. Engineering is the art of managing compromises. The Komet simply pushed those compromises to an extreme. Why the Do-335 deserves to be remembered. The Do-335 doesn't have the futuristic fame of the Ho-229. It doesn't have the rocket-powered drama of the Me-163. It doesn't have the jet-age significance of the Me-262. But it may be one of the most interesting examples of conventional engineering pushed to an unusual limit. 2 engines. One in front, one behind. A sleek fuselage. Heavy armament. High speed. It was an aircraft built around one question. How can we get more power without paying the aerodynamic penalty of a conventional twin-engine layout? The answer was elegant. But elegance is not enough. The aircraft arrived too late, and history moved on. The dead end that wasn't really a dead end. Many prototype aircraft appear to be failures because they never entered large-scale service. But that's an incomplete definition of failure. A prototype can fail as a weapon and still succeed as an experiment. Engineers learn. Pilots learn. Manufacturers learn. Future aircraft benefit. A failed landing gear system can prevent future accidents. A difficult wing shape can reveal an aerodynamic limitation. An unreliable engine can expose a materials problem. A prototype that never fires a shot can still influence aviation history. That is why experimental aircraft deserve attention. They represent knowledge. And knowledge rarely disappears completely. The final months of the Luftwaffe. By early 1945, the German aviation situation was desperate. Allied aircraft were operating almost freely over much of Germany. German airfields were attacked. Fuel shortages became catastrophic. New pilots had insufficient training. Factories were being destroyed or dispersed. The Luftwaffe still possessed technologically advanced aircraft, but technology could no longer compensate for the collapse of the system supporting it. A jet fighter without fuel was grounded. A prototype without spare parts was useless. A pilot without training was vulnerable. And a factory without raw materials could not produce anything. The aircraft of the future were trapped inside the war of the past. May 1945, the end. In May 1945, Nazi Germany surrendered. The war in Europe was over. The German prototype program stopped. Aircraft that had been under construction were abandoned. Factories were occupied. Research facilities were examined. Engineers faced uncertain futures. An aircraft that had once represented military ambition suddenly became evidence of a defeated regime. Some prototypes survived. Others were destroyed. Some were captured and shipped overseas. Others disappeared. The German aviation revolution had ended, but the jet age had only begun. The legacy of Germany's prototype aircraft. The German experimental aircraft of World War II leave behind a complicated legacy. They demonstrate extraordinary engineering creativity. They also demonstrate the limitations of technology when separated from logistics. The Me-262 showed that jet fighters could dominate conventional aircraft in speed. The Me-163 demonstrated the possibilities, and dangers, of rocket interception. The Ho-229 explored the flying wing concept. The Do-335 pushed piston engine performance in an unconventional direction. The Ta-183 represented the evolution toward advanced swept-wing jet fighters. The He-162 showed how desperation could accelerate development while simultaneously making aircraft more dangerous to operate. And the AR-234 demonstrated that jet-powered reconnaissance and bombing were no longer science fiction. Together, these aircraft form a snapshot of aviation at the moment when the old world was disappearing. The bigger lesson: there is a temptation to look at these aircraft and ask only one question. How advanced were they? But perhaps the more important question is, why weren't they enough? The answer reveals something fundamental about warfare. Technology is powerful, but technology operates inside systems. A fighter needs fuel. A pilot needs training. A factory needs workers. A worker needs materials. Materials need transportation. Transportation needs fuel. Fuel needs refineries. Refineries need protection. And the entire system needs time. Germany's prototype aircraft often demonstrated what was technically possible. But by the final years of the war, Germany increasingly lacked the ability to support what was technically possible. That is why these aircraft remained mostly prototypes. The sky after the war. The world that emerged after 1945 was radically different. Jet fighters spread across the planet. Swept wings became standard. Rocket technology advanced. Long-range bombers became faster. Radar became more sophisticated. Missiles began replacing guns as the primary weapons of many fighters. Aircraft became supersonic. And eventually flying wing concepts returned in new forms. The aviation revolution that Germany had experimented with during the war became part of a much larger global transformation. American, British, Soviet, French, and other engineers pushed aviation forward. The future no longer belonged to one country. It belonged to the entire world. The aircraft that never got their second chance. Every prototype represents a question. What if? What if the engine had been more reliable? What if production had started earlier? What if the aircraft had received enough fuel? What if pilots had enough training? What if the factories had not been bombed? What if the war had lasted another year? These questions are fascinating, but they can also be misleading. History is not a technology competition where the most advanced machine automatically wins. History is the result of millions of decisions. Political decisions, industrial decisions, military decisions, economic decisions, and human decisions. The German prototype aircraft were extraordinary, but they were developed inside a war that Germany was increasingly unable to sustain. The future was already in the sky. Perhaps the most remarkable thing about these aircraft is not that some looked futuristic. It's that they appeared when the world was still learning how to fly with propellers. In the same decade that young men were learning to fly piston-engine fighters, engineers were already building machines powered by turbines and rockets. The transition happened with incredible speed. At the beginning of World War II, the fastest combat aircraft were propeller-driven. At the end, jet aircraft were already appearing over Europe. Only a few years later, jet fighters would become central to the Korean War. And not long after that, humans would enter the space age. The prototype aircraft of World War II therefore belonged to a much larger story. They were part of the moment when aviation stopped being merely an improved version of the past. It became something entirely new. Final, the machines left behind. Today the engines are silent. The airfields have changed. The pilots are gone. The factories have been rebuilt or demolished. The political world that created these machines no longer exists, but the aircraft remain. A Me-262 sitting behind museum glass. A Me-163 preserved as a strange reminder of rocket-powered warfare. A Ho-229 displayed like a machine from another century. A Do-335 showing just how far engineers were willing to push conventional technology. A collection of prototypes that never became the weapons their designers imagined. They are not symbols of an inevitable German victory. They are not proof that one secret machine could have changed the war. They are something more complicated. They are evidence of human ingenuity operating under extreme pressure. They show what engineers can create when they are told that the impossible must become possible. But they also show the limits of invention. Because an aircraft is never just an aircraft. It is the product of factories, materials, fuel, people, training, maintenance, strategy, and time. Germany created some of the most radical aircraft designs of World War II. But by the time many of those machines were ready, the war itself was already collapsing. The future had arrived, just not in time to save the past. And perhaps that is the most haunting lesson of all. The skies of Europe were filled with machines designed for tomorrow. But the war was being decided by everything Germany could no longer provide today. Fuel, pilots, factories, numbers, and time. The prototypes could point toward the future. They could not stop history. Because in the end, the most advanced aircraft in the world is still only a machine. And machines can change the way wars are fought. But they cannot, by themselves, change the course of history. The German prototype aircraft of World War II were never simply forgotten experiments. They were glimpses of the aviation revolution that was coming. Some flew. Some crashed. Some remained drawings. Some became operational too late. And some survived only as museum pieces. But together they tell the story of an era when the sky itself was changing. The propeller was giving way to the jet. The conventional airplane was giving way to radical aerodynamic concepts. And the technology of the future was being born in the middle of the world's most destructive war. The aircraft were ahead of their time. The war was not. And that is why, decades later, their stories still fascinate us. Because when we look at these strange machines, we aren't only looking at what Germany built. We're looking at the moment aviation crossed a line between the aircraft of yesterday and the aircraft of tomorrow. And somewhere in that silence, inside the museums and hangars where these machines now rest, you can still see the question their designers were asking. How fast can we go? How high can we climb? How far can we push the limits? And perhaps the most important question of all, what happens when the future arrives before the world is ready for it?